Good afternoon, everyone. My name is Ruochen Zhou from Zhejiang University. It is a great honor to be here to present our work, DeHiREC, detecting hidden voice recorders via ADC electromagnetic radiation. So hidden voice recorders have become smaller, like a pen and USB, or power bank, or something else that are hard for us to notice. Therefore, it becomes a threat to leak sensitive information. So in this work, we try to answer this question: how to detect these hidden voice recorders. And the existing available method can be mainly divided into two categories. One is traffic-based detection, which detects online recorders by identifying the wireless traffic patterns, but they cannot detect those offline recorders, which save the audio files locally. And the second is reflection-based detection, which uses a nonlinear property of semiconductors inside the electronics. However, it fails to confirm or distinguish whether the device is a recorder or other device, so results in a high false positive. And so here's a further question: that how to detect offline hidden recorders reliably. And our basic idea is that even offline devices will emit signals known as electromagnetic radiation, or EMR, which is generated by the varying current inside the electronic components of recorders. And we try to identify a recorder by measuring its radiation. So here's a quick overview of our system based on the key idea. And as a detector, we imagine that by installing an antenna under the conference table to receive the radio frequency signals, and once a detector is recording, the radiation from the recorders will be captured by our system, and the alarm will be issued. So, and ideally, the system should have these requirements. First of all, the system should be able to detect both online and offline recorders. And it needs to achieve a lower false positive, which means it will not alarm when there are non-recorders or recorders which are not in recording. And we also want the system hard to notice by the attackers. So to implement our system, we need to firstly answer two questions or research questions. The first one is, what is special about this radiation from recorders? That is EMR Characteristics. And we focus on the recording process, specifically the AD conversion process, and we hypothesize that the ADC will radiate unique radiation patterns. However, ADCs are widely used in a lot of devices. So here comes the second question: is that how to reliably detect a recorder among various devices with ADC, that is EMR Distinctiveness. So we did a preliminary test to capture the radiation of recorders, and we studied two recorders and captured the radiation when they're recording and not recording, and get the spectrum in the picture. So here's our observations. First of all, we can see the radiation, which is the peaks, as we marked, are distributed at equal intervals in all these spectrums, which is the feature of harmonics. And also, we find that when the recorder is recording, there comes up more peaks than that they are not recording. So based on this result, we hypothesize that the ADC in operation generates harmonics EM radiation. And further, we compared the frequency with the datasheet of the voice recorder's chips. Take so-called C1 recorder, for example. The radiation frequency is 3.23 megahertz when they are recording, which matches the ADC clock in the datasheet. So, and the result of another recorder is also the same. So here's our answer to question one: is that the electromagnetic radiation of recorders contains frequency components determined by the ADC. So as we talked before, ADCs are widely used in other devices, so how to identify the radiation from recorders. and we try to find a way to change the radiation actively. We first manually cut off the input of the ADC during the recording process, which is the one connecting the microphone and the ADC, shown in the picture, and we get the result on the right. And we found that when the input of ADC is lost, the strength of radiation drops greatly, which means that the strength of radiation is determined by the ADC's input. So if we try to identify or distinguish the EMR is indeed from the recorder, we can change the input of the ADC. And the question is how to change this input. And we simplify the workflow of recorders as to this picture. And intuitively, there are 3 methods to change the input. The first one is audible sound, but it can be heard by the attacker, so we passed. And the others are the ultrasound injection proposed in the pioneer work dolphin attack and the electromagnetic interference injection proposed in the dolphin attack. So we conduct a feasibility test to Zhou C1 to evaluate it, and we got the results on the right. So we found that EMR injection can greatly increase the strength of radiation, but the ultrasound injection gets a poor performance. So we choose EMR injection to actively stimulation. The key to stimulation is that the EMI frequency needs to match the resonant frequency of the circuit. So we observe the wires of several recorders, which are the white box in the picture, and we found that the length of wires is normally less than 3 centimeters due to the small size. And according to the electrical length, the converted EMI frequency needs to be greater than 500 megahertz. And we also noticed that there's a low-pass filter inside the recorder, so we modulate a 1 kilohertz signal on a high-frequency carrier to bypass the filter and inject EMI signals. We give the stimulation result of other 2 recorders when the EMI frequency is set to 918 megahertz. So in summary, our answer to question 2 is that once we find a spectrum with similar characteristics to the voice recorder, we will inject EMI signals to perform a secondary verification. And finally, we designed our detection system, DeHiREC, which is mainly divided into 2 stages. The first stage detects the suspicious radiations through preliminary screening. And the second stage performs EMR stimulation and verify that the radiation indeed comes from the recorder. We build a prototype system as shown on the left, including the EMR probing and the EMR measuring. And our targeted devices are certain voice recorders with various shapes or shells. And the overall performance of our system is shown in the table. The time cost for one detection is around 3.8 seconds. And our system is able to successfully detect all 13 recorders with a true positive rate of 94% at a distance of 10 centimeters. And we also find the metal shells causes a lower detection distance due to the attenuation. And we also tested interfering devices to evaluate the system true negative rate. And we selected some of the other types of devices, and we found that most of them do not respond to our stimulation, and the average true negative rate is 95%. Finally, we tested DeHiREC in our real-world sim meeting room. And we choose some interference devices and put them in places where they appeared normally, such as the conference system in the middle of the table and the laptops in front of each seat. And we implement our prototype under the table. the distance between the seat to the antenna is around 20 centimeters. And we simulate 6 cases to evaluate the performance. And in each case, the working interfering devices are different. So, and a total of 718 rounds of detection is performed, and the overall detection accuracy is 92% with a recall of 86%. And we also found that in real world, the interference from other devices can be mitigated when the devices are reasonably planned. Here's a quick summary for our work. We discovered the general EM patterns resulting from the ADCs of recorders, and we propose EMR stimulation, an active method to trigger the radiation to vary in reaction of our EMI injection. And we built the first proof of concept system, DeHiREC, to detect recorders based on the weak radiations. And our evaluation on 13 voice recorders and 21 interfering devices show the effectiveness. And that's all of my talks. Thanks for your listening.
We just have a time for one question. So.
Oh, okay. Nice talk. Very interesting work. I cannot help noticing that you use kind of the professional voice recorders in your simulation. I wonder if I use my smartphone or use my laptop to record, is it able to use your method to detect those voice recorders?
Oh, thanks for the question. And in our paper, our scenario is that to detect the hidden voice recorder, which are small-sized, but and we found that underlying cause of the such radiation is that the chips they adopt, which we call the mixed signal cis-NR chip, and we found that these chips will be adopted by other types of recording devices, such as the conference system or smart speaker. But in smartphones or laptops, they use a different model of chips, so our system cannot detect those recording smartphones or laptops. And I think it is a future study direction to detect the recording smartphones.
Okay, thank you.
Maybe we can take that offline. Yeah. So thank you, Ruochen, for the great presentations, and we can give him a